Hello dear friends, welcome you all for our first session of chemistry. It was supposed to be done last Wednesday, but because of some technical issues we couldn't conduct it on Wednesday. So I'll be beginning from the beginning that of basic concepts of chemistry. So I think all of you might have already done with inorganic chemistry. So you have been already introduced to inorganic chemistry. So my part is physical chemistry, and I am Karthik, a chemistry teacher, and I'll be taking physical chemistry for all of you. Okay, yes. So beginning with our discussion, basic concepts of chemistry, I want interactive sessions from all of you, whoever has joined. So whatever question I am asking, maybe you can try to type it down on the chat box. Okay, fine. Yes. So what exactly do we learn in chemistry? Yes. So, okay, 1 minute. Hope now it's clear. Now is my voice clear? Yes. Yes, so branches of chemistry. Okay, fine. So let us continue ahead. Chemistry is the branch of science which deals with study of material of object, study of material or object. Yes. So question for all of you is, tell me what is matter. Okay, whatever is made in the universe, we account them in matter, and study of that matter itself is chemistry. And I hope you all might have studied some basics of chemistry. By chemical bonding, everything will be known to you, isn't it? Yes. So every object has some property, isn't it? So there is mass, there is volume, density, refractive index, all of this come under properties of matter, and these properties are of prime importance for us for understanding and application of that matter. In broad view, I can classify these properties into chemical properties and physical properties. Physical properties we will not deal with it in chemistry as such, whereas chemical properties is what we will be learning in chemistry. And the journey of this chemistry has been from long ago, that is from Vedic times. You all might have heard about parasmani, which whenever touched on any substance converts it into gold. And then came alchemist theory. There were certain set of people who were in search of experiments to convert any material into gold. And then by 19th century, our Dalton proposed Dalton's atomic model, and from there our journey of science in chemistry began. Yes, so coming to chemical properties, the property which can be evaluated by undergoing some chemical change in matter are called as chemical properties of matter. So physical properties has nothing to do with the chemical composition, or you need not to change chemically the matter itself, whereas in chemical property you have to change. For example, if I tell hydrogen is very combustible, my dear student, so you will ask me, how sir, how is it combustible? So to understand that, what we need to do, we have to burn it. If it rigorously reacts with oxygen, then that means it is highly combustible. Okay, so these are the chemical properties which happens at the cost of matter itself sometimes. Yeah. Okay, so I didn't get any reply for matter. You all can send right in WhatsApp in the chat box the definition of matter. Yes, anything which has mass and occupies space, isn't it? Okay, so now this matter can be classified into two main subdivisions, which is physical classification and chemical classification. So in physical classification, that is mainly based on phase. So if it is solid, that means if it has definite volume and definite shape, then we call it as solid. If it has definite shape, definite volume but not definite shape, we call it as liquid. And if it does not have definite shape and volume, then we call it as gas. Okay, coming to chemical classification, if the matter is pure in nature, then we call them as pure substances. I'll just elaborate. For now you can know there are something called as pure substances, something called as mixtures. So if I want to understand chemical classification, obviously I will have to go in depth, isn't it? Because every matter consists of molecules. All of you might be knowing this. And based on the property of molecule, property of the matter depends. Hence, coming to basic level, I have to understand the property of molecule. Then only I will be able to use that matter by understanding the property as a whole. Okay, so if in a matter it consists of pure atoms or purely one type of molecule, then we call it as pure substances. Okay, one type of molecules, then we call it as pure substances. Now if it contains only one type of atom, it is called as elements. If it contains only one type of molecules, which is combination of atoms, then we call it as compounds. Okay, yes. So further going ahead, elements can be classified into metals, non-metals and metalloids. Okay, just wait for a while, students. Yes, so pure substances can be broadly classified into elements as well as compounds. So elements are nothing but which are composed of similar type of atoms, whereas compounds are composed of similar types of molecule which are combination of atoms, in a fixed proportion. Okay, so for example, it could be H2O, it could be CO2. Yeah, all of this come under the category of compounds, whereas in category of elements I can say H2 or helium or O2, all of these are containing single atoms, right? So these come under the category of elements. Okay, yeah, hope my voice is clear now. You can kindly reply. Yeah, so coming to the other part, that is mixtures. So mixtures are the other set of matter, or classification terms. It is another set of matter which is combination of two different compounds or elements. For example, salt and water. Okay, so salt and water, here two different molecules are mixed, so they can be mixed homogeneously, that means all together it is mixed in a proper fraction, or it can be mixed in heterogeneous way. Okay, so based on that I have a classification as homogeneous as well as heterogeneous. For homogeneous, best example is salt and water. For heterogeneous, example could be rice and maybe pebbles in it or small stones. Okay, yes. So going ahead, elements, there are broadly three classification: metals, non-metals and metalloids. You all might have heard this in periodic table, isn't it? Periodic table consists of elements, in which the left of the periodic table will be metals, in between I will have transition metals, and then metalloids, and then non-metals. Yeah, all of them are elements only. Okay, and if these atoms combine together in fixed proportion, they will form compounds, either inorganic compound or organic compounds. Okay, so inorganic compounds means those compounds which are formed without using carbon. All the compounds which are not having carbon in them, we consider them as inorganic compound, and all the compounds which have carbon as one of its atom, we call them as organic compound. So this is the broad classification of matter, and the chemistry is the study of the whole table that you are seeing on the screen. Okay, yes. So based on this understanding, let me now explain to you what are the various branches of chemistry. So broadly there are four branches. One is inorganic chemistry, organic chemistry, physical chemistry and analytical chemistry. So inorganic chemistry is concerned with the study of elements other than carbon. I said, right, inorganic compound means compound formed with elements other than carbon. Yeah, and inorganic chemistry is study of elements which are elements and their compounds which are found without carbon in them. Okay, yes. Organic chemistry is the other section wherein whatever is excluded in inorganic chemistry, that means carbon we didn't study in inorganic, right? So that we will be studying in organic chemistry. Okay, it will be concerned with organic compounds which are containing carbon. Why a separate study of organic chemistry is needed? Because of the catenation property of carbon, because of which it forms various number of compounds, and that's why we have a separate set of study. Okay, yeah, and from competitive perspective, 1/3 of the questions will be from inorganic chemistry, 1/3 will be from organic chemistry. Going ahead, we have physical chemistry. Physical chemistry is concerned with explanation of fundamental principle. So, for example, in physical chemistry, we will be learning few principles which all matter should obey. So, when I tell solid, solids are incompressible. You cannot compress solid object. So, this happens to be the principle of physical chemistry. And similarly, there are many more principles. And I'll tell you students, physical chemistry is just about logic. If you understand the logic properly, systematically, you can score even JEE advanced, even the level of JEE advanced can be scored very well in physical chemistry, and this carries little more than 1/3 of the paper. Okay, so you can understand how much physical chemistry is important, and most of the serious students who want to score well aim at physical chemistry, organic chemistry. Okay, so if you are good at logic, aim at these two, physical chemistry and organic chemistry. Inorganic chemistry, if you are good at learning things, then go with inorganic chemistry. That also can give you good mark. Okay, coming to analytical chemistry. So what is this analytical chemistry? Any compound to be discovered had some certain procedures, right? So that procedures we will be studying in this section through qualitative and quantitative analysis. Broadly telling, I can say that qualitative means which atoms are present in the given compound. Which atoms are present in given compound can be found out by qualitative analysis. And how much proportion, what is the ratio of given atom in the given compound, can be found out by quantitative analysis. So this is also kind of numerical. So hence this also, if you know certain set of formula and everything, you can score well in analytical chemistry also. There is no separate section. It will be directly, the questions will be based on this plus this and this plus this. Only few questions will be there, but it will be included in inorganic chemistry as well as organic chemistry. Okay, yes. So these are few of the basic idea that I wanted to give to all of you. Now we are going into the physical chemistry part. Okay, once we have got the broad view of what exactly our chemistry deals with. Okay, yeah, from now on I would want you to comment on chat box whatever questions I am asking, whatever doubts you are having anywhere, and any other queries if you have. Okay, yes. So going to overview of the chapter, there is physical quantities and unit that we will be looking it in this class, and then there are measurements and significant figures, laws of chemistry, mole concept, concentration terms, and stoichiometry. So today we will be looking majorly on this, and these are few of the topics which are most important. Direct question comes from laws of chemistry, sometimes mole concept. If this is clear, whole 11th 12th physical chemistry will be clear for you, so you can understand this very nicely. Concentration terms, even this happens to be most basic and important one. And last one is stoichiometry. Okay, yes, even this is quite important, so let us do it step by step. Okay, physical quantities and units you might have already learnt in physics. Yes, so there are 7 fundamental units, 7 fundamental physical quantities, and then there are secondary quantities, and then there are derived quantities. All of that will again revise once, and then further we'll look into various other aspects. Okay, yes. So all of you can type now in the chat box what is your weight, how much weight, what is your weight, as well as what is your height. Okay, yes, let's go ahead. Physical quantities. So what are these physical quantities? Anything which can be measured is called a physical quantity. For example, distance from Chennai to Hyderabad. Yes, so it can be measured, correct? It can be measured. So this can be quantified as one physical quantity. Similarly, weight of somebody. can also be a physical quantity because I can measure it, isn't it? But then there is one problem with reference to what, isn't it? For example, if I ask some alien who has landed just recently, okay, if I ask him, sir, what is radius of your planet? What could be his answer? Yes, what is radius of your planet? What could be his answer? Yes, his answer will be shocking to us because we don't know what unit he is speaking in, isn't it? In the same way, if you answer to me that your weight is, let's say, 45 kg, sir, or 50 kg, and I don't know what kg is, then it doesn't make sense to me. Okay, 45, what it is, 50, what it is, I don't know. So that's why we should have some standard unit all across the globe, okay, and that should be associated with all the physical quantity. If I want to say Chennai to Hyderabad, what is the distance? I can tell it is this many kilometers. Yes, so kilometer will be a unit, which is very important. So every physical quantity will be associated with some unit to it. Okay, yeah, the value of a physical quantity is expressed as the product of numerical value and the unit in which it is expressed. Okay, now this physical quantity could be of two types, fundamental as well as derived. So what are fundamental quantities? Which are not dependent upon some other quantity. For example, your height is not dependent upon your weight, isn't it? So your height may be 140 centimeter and your weight may be 45 kg. So your height is not dependent upon your weight. So these two are two different fundamental quantities. Okay, whereas derived means it will be dependent upon some other fundamental quantity. For example, volume. Volume is dependent upon height. For example, if say I take a cube, of side 10 centimeter, then volume will be dependent upon the sides, correct? So it will be 10 centimeter whole cube. So it is dependent upon side, length of the side. So 1000 centimeter cube. Such quantities which are dependent upon some other fundamental quantity are called as derived quantities. Clear? Yes, I want active chat box students. You can utilize my energy fully. Yeah, I want you all to interact. If you are having any doubt, you can post it. If you are if I am asking you any questions, you can kindly put it in the chat box. Okay, yes, I think Sarayu and Ridhishri, both of you can be active. Okay, yes, so fundamental quantities, these are the physical quantities which does not depend on any other physical quantity. They are fundamental quantities, as I said, height or length, mass or weight, yeah, and time. Yeah, weight, when I come to physics, it becomes little different, so I will not use weight, you can just stick to mass. Okay, derived quantities, the quantities that can be obtained from fundamental sets are called derived quantities. Example I already gave, volume, yes, density also could be, yeah, many derived quantities are there. Okay, and the units of derived quantities are also derived from units of fundamental quantities. You can please make a note of it. Fine. Yeah, so there are basically 7 fundamental quantities which you might have already learnt in your physics. They are mass, length, temperature, amount of substance, time, electric current, luminous intensity. Yeah, so mass is very easy, which you all might be knowing. Length is also very easy. Yes, temperature also you might be knowing. Amount of some substance is something new which I will be explaining to you now. Time also, you know, time also is a fundamental quantity. It is not dependent upon any other fundamental quantity, so it is a fundamental quantity. Electric current, yes, this is also not dependent upon any other fundamental quantity, so it is also a fundamental quantity. Luminous intensity, has something to do with intensity of light. Okay, yes, so that is also independent. Amount of substance is the total number of molecules. Yeah, this amount of substance is used to measure total number of molecules in the given sample. Okay, it is the unit of it is mole, and more about it I'll explain in the subsequent classes. Okay, apart from this, there are supplementary quantities also. They are plane angle and solid angle. Okay, what are this plane angle and solid angle? The angle which we measure in 2 dimension are plane angle. The angle which we measure in 3 dimension are solid angle. Okay, so usually the unit is radian, you all might be knowing, and the unit of solid angle is steradian. Okay, yes. As I told previously, I told you one example, right? If an alien comes to me and if I am very curious to know about radius of their planet, there will be no answer for it, isn't it? So in the same way, the controversy used to happen previously. What was that controversy? Americans were used to FPS system. Okay, they were knowing only foot, pound and second, and we probably don't even know how much is 1 pound, isn't it? Foot also we know because our heights are in feet, we measure it in feet. Okay, yeah, so Americans were used to this FPS system wherein they used to measure length with foot, mass with pound and time with second. And then there were Britishers which were used to MKS system. What is this MKS? They used to measure length with meter, scale as meter, mass as kilogram and time as second. So when some research happens between America and British, there will be a controversy saying that we are not able to understand what exactly it is meaning. So because of this, we came up with International System of Unit. So that means what? All over the world there should be only one system which we call it as SI system. Okay, so MKS got finalized as SI system. Clear? Yes. Okay, so based on this SI system, we got certain SI unit for each one of them, and they have got definition also. Strange to know about it. Yes, length, it is defined as meter, and this meter, there is one laboratory in the world where they have maintained the length of 1 meter, how much exactly it is. So based on that definition, they use meter. Okay, mass, the unit they have kept as kilograms, and the weight of this is kept in one universal world laboratory where they have a standard measurement of kilogram. Time, the unit they have kept it as seconds. Electric current, unit ampere. Okay, all of this have some basic definition which are possible to explain. I am explaining. Which are not possible, like it is kind of beyond scope, so we will not worry so much about it. Time also can be explained as 1 by 299,728,000 approximately. I am approximating this much amount of time required for a light to travel is called as, this much length for a light to travel is called as 1 second. Okay, basically it comes out to be 1 second. Okay, thermodynamic temperature. Temperature we use it in Kelvin. Yeah, how Kelvin came into picture? Kelvin came into picture based on the fact that the melting point of ice is 273.15 Kelvin and boiling point of water is 373.15 Kelvin. Okay, so based on this we have a scale, temperature scale, which is Kelvin. Okay, one more interesting fact, this Kelvin can never be less than 0. Okay, temperature in Kelvin can never be negative. That is the interesting part. And if you try making some temperature in this universe less than 0 Kelvin, maybe you take isolated box and somehow you make it the temperature of that box less than 0 Kelvin, then it ceases to exist. Electron motion stops, atoms random motion stops, everything stops below 0 Kelvin. Okay, based on that we have this temperature scale. Amount of substance, as I have already told you, the unit of amount of substance is mole. Okay, what is this mole? Anyone can type in the chat box if they are aware of mole. Yes, in 10th you might have studied, na? It is the number of particles which is equivalent to 6.022 into 10 power 23 atoms of 12C carbon. Yeah, that itself is mole. Okay, and luminous intensity is candela. Okay, it is given as CD. Okay, and plane angle unit is radian, solid angle unit is steradian. Fine. Okay, so now there are certain non-standard units also. For example, can you all explain me how much tea you drink every day? Yeah, can you just type down your answer, how much tea you drink every day? Okay, yes, let's go ahead. Relation between standard units. One is prefix based relation and definition based relation. So prefix based relation has something to do with prefix. For example, meter and millimeter are related to each other by a prefix milli. So milli means, which we will see later, 10 power minus 3. So 1 milli means 10 power minus 3. So these two are related as follows. 1 millimeter, instead of milli I can use 10 power minus 3 meter. Clear? Yes. So these are prefix based relation, and then there are definition based relation, which I'll explain a little later. Quintal, for example. Okay, 1 quintal is 100 kg. So quintal is definition of quintal is 100 kg. Okay, which is not a prefix. So if I tell 1 quintal, it will be 100 kg. Okay, fine. Yes. So if you are understanding, you can please type yes sir. Okay, because I don't know any other way to verify. Okay, so then there are yeah, also I didn't get the answer for how many cups of how much tea you drink every day. Yes, I expected answer to be 2 cups sir, or 1 cup. Okay. Yeah, so basically the point is that 1 cup or 2 cup is non-standard. You don't know, I don't know your cup consumes how much volume, what will be the volume of your 1 cup, I don't know. So it is non-standard unit. Clear? Yes. Going ahead, conversion methods. So the conversion methods for various standard units based on definition or based on prefix or based on dimensional method, which is for derived physical quantities, which we will look at it later. But prefix based and definition based, when they are there, what are the how to go about solving such question is what we are going to focus now. And get alert, this is where questions can come. Okay, NEET, JEE, all competitive exams, this part is important. Okay, yes. So let's say if I have told you, sometimes questions may come, if you are lucky enough, such questions may come. How many quintal is 20 kg? Okay, so these are questions based on definition based conversion. So what is the definition of quintal? 1 quintal is 100 kg. So this definition you should be knowing. So if 1 quintal is 100 kg, 20 kg will be how many quintals? Yes, I'll go ahead. You can please type down the answer if you get for this. Okay, there are few more definitions like atomic mass unit, which is defined as 1/12 of, okay, wait, I'll take this in maybe upcoming classes. 1 angstrom can be written like this also, which is 10 power minus 10 meter. This is usually used for wavelength. Okay, wavelength is expressed in angstrom. And then 1 foot is 30.48 centimeter. Sometimes you consider it as 30 centimeter, but exact value is 30.48 centimeter. Okay, coming back to this, 1 quintal is 100 kg, then 20 kg will be how many quintals? Yes, so to get the answer for this, I will have to do cross multiplication. So when I do cross multiplication, I'll get 20 into 1 by 100, okay, which is equal to 0.2. How it is 0.2? Two zeros are there below, so I'll have to move 2 decimal places, which will give me 0.2. Unit is quintal. Okay, so cross multiplication is the best technique to solve the definition based conversion. Okay, 1 kg is also defined as 2.2 pound. Okay, and then there are prefix based conversion. Yes, so there can be certain times there can be some prefixes used. For example, if say your height, if I am asking, you may tell it in centimeter, which is not a standard unit, which is not according to our SI system, but it can be related to SI system when I use this power. Okay, so wherever 1 centimeter, wherever 1 centi comes, you should remember 10 power minus 2 will come over there. Okay, so in place of C, you will put 10 power minus 2 meter. Okay, this is what is prefix based conversion. Clear? So if I am telling you 1 micrometer, how much it will be? 1 micrometer means, where is this micro? Okay, the unit of micro symbol is like this. Then 1 micrometer will be equal to 1. In place of micro, I have to put 10 power minus 6 meter. Got it? Yes. Yes. Please students, if you are understanding, you can please type in the chat box. Okay, yeah. So if say kilobytes, yeah, if I am telling you I have a file of size 1 KB, 1 kilobyte, what does that mean? It means that I have a kilo, where is kilo? Here it is, 10 power 3. So I have a file whose size is 1 into kilo means 10 power 3 bytes. Okay, which is 1000 bytes. Clear? So similarly, I can say 1 gram. Yeah. So 1 gram is not a standard unit, isn't it? Yes. So kg is my standard. Kilogram is standard. Kilogram is standard. So how can I get, if 1 gram is given, how can I get in terms of kilogram? Yes. Again using the same logic, kilogram means 10 power 3. In place of kilo, I can write it as 10 power 3 grams. So 1 gram means how many kilograms then? If 1 kilogram, if it is 10 power 3 grams, then 1 gram will be how many kilograms? Again you can do cross multiplication. You will get 10 power minus 3 grams. Okay. Yes. So these are few examples. Hope you are understanding with these examples the prefix based conversion. Okay. Yes. So one more interesting thing just to add to this, whenever you are sharing some file, okay, or whenever let's say you have a folder in your mobile or computer, you may observe that when you are go on adding files into it, initially it will be in kilobytes, okay, KB, and after that it increases once 1000 KB is reached, approximately when 1000 KB, exact value is 1024 KB. When it reaches kilo becomes mega, okay, 1 megabyte. Note down, kilo is not capital whereas mega is capital. Okay, and then when you further increase 1024 megabytes, it will be 1 gigabyte. Okay, so 1000 increases, whenever 1000 gets increased, then kilo become mega, mega becomes giga. Yes. So going ahead, we are, hope you all are understood about fundamental quantities. Now we are going into derived quantities. So few derived quantities which you have already learned, maybe speed, velocity in physics, acceleration, force, pressure somewhat, yeah, kinetic energy also you might have learned somewhat, power also you might have learned, density, maybe you might be familiar with density as well, isn't it? And these are few which are related to chemistry or thermodynamics in physics. Heat, specific heat, thermal capacity, latent heat, gas constant, Planck's constant. Yes, Planck's constant, I think in atomic structure you might have heard about this. Okay, unit is meter per second square, Newton, Pascal, Joule, Watt or joules per second, kg per meter cube. Heat unit, basically it will be joule, but there are various other units like calories. Then we will look into it when we are going into that. We will look into it. Then specific heat will be joule per kg Kelvin. Then thermal capacity, joule per Kelvin. Gas constant, which is very important, joule per mole per Kelvin. There is another unit also which we come across frequently, liter atm per mole Kelvin. Don't ignore this, my dear friends. This is also important. Okay, if you know these units properly, when we go into chapters you will understand it more nicely. Okay, yes. So density unit in SI system is kg per meter cube, but we also use gram per cc. Okay, Pascal is SI unit of pressure, but we use few other units also. Okay. Okay. Yes. So now let us go ahead and try to understand how to solve a given question by dimensional analysis method or unit factor method. Till now whatever I have told you is based on cross multiplication, correct? So for example, if 120 centimeter has been asked to convert into meters, so then you can use the information 1 meter is 100 centimeters, sir. So 120 centimeter will be dash meter. So this is one way to do, which is cross multiplication, or you can also do it by using unit factor method. Okay, which also I have given a glimpse. So for example, you have 10.56 meter. If you want to convert it into centimeter, you write the unit factor. What is that unit factor? 1 meter is 100 centimeter. So you write that 1 meter is 100 centimeter. So the answer will be, what will be n? Centimeter can get cancelled. N will be 1056, 100 into 10.56, which is 1056. Clear? Similarly, if say it is given to you 110 centimeter into meter, then how to do? You know that from the basic unit, you know 1 centimeter is 0.01 meter. How are we getting this? From the understanding that 1 meter is 100 centimeter. So 1 centimeter will be 1 by 100. This I can take below. This I can take below. So it will be 1 by 100 meter, which is 0.01. 2 decimals you will have to move. Okay. So I'll write this 1010 in place of centimeter. I'll write 0.01 meter, which will be equal to n meter. So n value will be, move 2 decimals, it will be 10.1. Clear? This is unit factor method, for which you should be knowing what is the unit factor, okay, which you need to multiply with. Clear? Yes. So going ahead, there are few physical quantities, derived physical quantities, which are important. They are volume, temperature, density, pressure, energy, heat. All of these physical quantities we will look into it very often in chemistry. Okay, so I want to introduce you to few basic units of volume, temperature, density, pressure and energy. Okay, yes. So when I tell volume, it's generally expressed in liters or centimeter cube or decimeter cube, sometimes in meter cube also. So 1 meter cube is the SI unit, volume in SI unit, meter cube. And to understand this more nicely, I'll tell you from smaller to bigger. The smallest of all is 1 centimeter cube. Okay, 1 centimeter cube is very small. 1 centimeter cube, that's all. A cube of one side, a cube of side 1 centimeter, that is 1 centimeter cube. When you put 1000 of it, it becomes, okay, this 1000 if you take, okay, thousands of 1 centimeter cube samples if you take, that will make 1 liter or 1 decimeter cube. Okay, and when you take 1000 of that, that will make 1 meter cube. Clear? Yes. So from this I can clearly say that 1 liter will happen when I use 1000 centimeter cubes. So it will be 1 liter is 1000 centimeter cube. And when will I get 1 meter cube? When I take 1000 of 1 liter. So 1000 of 1 liter, or instead of writing 1 liter, I can get 1000 liter directly, will give me 1 meter cube. So from these two, I can easily say 1 liter is 1000 centimeter cube. So I'll write it 1 meter cube is 1000 into 1 liter. In place of liter, I'll get 1000 centimeter cube, which will give me 1000 into 1000. How much it is? 10 power 3, right? 1000 means 10 power 3 into 10 power 3 centimeter cube, which is equal to 10 power 6 centimeter cube. So that's how we are getting this relation. 1 meter cube is 10 cube liter, which is also equal to 10 cube decimeter cube, which is also equal to 10 power 6 centimeter cube. Okay. Yes. Yeah, students. Hope you are all understanding, or is it I'm not getting any reply from all of you. Can please reply if you are understanding. Okay. Yes, going to question. Convert 10.2 liter into cc and meter cube. Always remember, cc when it comes, it is nothing but centimeter cube. Okay, that is another way of writing centimeter cube. And meter cube. So I can use the unit factor method, which is known to me. I know that 1 liter is 1000 centimeter cube, correct? So 10.2 liter is given to me, which I have to convert to n centimeter cube. So in place of liter, now I am going to write this, which is 10.2 into 1000 centimeter cube, which is equal to n centimeter cube. Centimeter cube can be cancelled. So n will be 1000 into 10.2, which is 10200, moving 3 decimal to the right. Okay. Yes. If you want in meter cube, how to do it? We know relation, the unit factor is 1 meter cube equal to 1000 liter. Yes. So, but liter is given to me, not meter cube. So I have to find out 1 liter is how many meter cube, isn't it? Since liter is given to me, I should have unit factor for liter. Yes. So if I want 1 liter, I will have to take this below. So if I want to take this below, it will be 1 by 1000 meter cube. So 1 liter is 10.2 liter, which is equal to n meter cube. So in place of liter, I am going to write this, which is 10.2 to 1 by 1000 equal to n meter cube. So on simplification, I'll get move 3 decimal to left, 1, 2 and 3, which will be 0.0102 meter cube. Clear? Yes. Second is temperature. As I already told, SI unit of temperature is Kelvin. Yeah, and Y also I have explained. Yes. So all these 3 temperature scales are related to each other. Okay, what are the 3 temperature scales? You might have studied in 9th, right? One is Celsius scale, one is Kelvin scale, one is Fahrenheit scale. What is the basis for Celsius scale? Water freezes at 0 degrees Celsius. We consider at 0 degrees Celsius water freezes and boils at 100 degrees Celsius in Celsius scale. Whereas in Kelvin scale, water freezes at 273.15 Kelvin and boils at 373.15 Kelvin, which I have already explained. And in Fahrenheit scale, water freezes at 32 degree Fahrenheit and boils at 212 degree Fahrenheit. And there is one expression between Celsius scale and Fahrenheit scale. Hope you all might be knowing about that. Yes. Yes. So let's try deriving it. Okay. Yeah. So the temperature can be measured with 3 scales. One is Celsius, one is Kelvin, one is Fahrenheit. Yeah. And the logic of the scale is in such a way that if you, let's say, make a 10 centimeter line, and in 10 centimeter line or some unit line, and in that unit line, if you are marking 0 degrees Celsius at one end and 100 degrees Celsius at another end, and same length, for same length, if you take another line of 10 centimeter, and if you make 273.15 Kelvin on one end and 373.15 Kelvin on another end, and if you take a third line which is 10 centimeter and make 32 degree Fahrenheit on one end, mark 212 degree Fahrenheit on another end, then if you want temperature for any other scale, given that if Celsius is given to you, if you want temperature for Kelvin or Fahrenheit, it will lie on the same line. That means the distance from this point to this point in all the lines will be same. Okay, so whatever value you get over here, that will be the temperature in Fahrenheit. Okay, let's say if I take X or say degree Celsius as temperature, and let's say Kelvin is the temperature in Kelvin, and F is the temperature, degree F is temperature in Fahrenheit. Okay, or one more thing I want to mention over here, Kelvin, the temperature, the unit of temperature in Kelvin will not be with degree, it will be just K. Okay, so then going back to my discussion, that the temperature in degrees Celsius, this length, okay, which is degree Celsius minus 0 degree Celsius divided by 100 minus 100 degree Celsius minus 0 degree Celsius, okay, this should be equal to, this temperature is, let's say, Kelvin minus 273.15 divided by 373.15 minus 273.15. Okay, this should be equal to this, and that should be equal to degree Fahrenheit minus 32 divided by 212 minus 32. Okay, yes, that is the magic of all these three scales. Okay, so their scale is same. Clear? So relative distances are same. So in that way, if I want to say, if I solve it, I'll get degree Celsius minus 0 by 100, Kelvin minus 273.15 by 100, and degree Fahrenheit minus 32 by 180. Okay, yes. So from this, if I want to get relation between degree Celsius and degree Fahrenheit, it will be degree Celsius by 100 into 180. I am taking 180 to the other side, equal to F minus 32, isn't it? So if I solve this, it will be 9s are 5s are. So this unit you might be already aware of it. Degree Fahrenheit is 9 degrees Celsius by 5 plus 32. Okay, this was the unit which you have, this was the formula which you have already used for conversion of degree Celsius to degree Fahrenheit. Okay, yes. Fine. Next, let's look at this question. Convert 25 degrees Celsius into Kelvin and degree Fahrenheit. So either we can use this relation, the previous one which we did, or we can go with our understanding. What is that? Temperature T in degrees Celsius plus 273.15 will be equal to temperature in Kelvin. Okay, so in that way, so temperature in Kelvin would be 25 plus 273.15, which is 298.15 Kelvin. Okay, and if you want in Fahrenheit, you can use directly the expression which we have already found out, 9 by 5 into degree Celsius plus 32, which is 9 by 5 into 25 plus 32. If I solve it, it will be 45 plus 32, which is 77 degree Fahrenheit. Clear? Yes, so it is 298.15 Kelvin and 77 degree Fahrenheit. Okay, going ahead, density. So density is nothing but mass by volume, which you all might have already studied, and then it is measured in gram per cc or kg per meter cube. Okay, I think it's already 7. Give me 5 minutes, I'll complete it off. Okay, yes. So the unit conversion, I'll just give you directly the between kg per meter cube and gram per cc. 1 gram per cc equal to 1000 kg per meter cube. Okay, so if say 13,600 kg per meter cube is given to you in this question, density is given as 13,600 kg per meter cube, then its density D in gram per cc if you want to calculate. Again, we remember unit factor method, isn't it? So n gram per cc I want, given is 13,600 kg per meter cube, and I know 1 kg per meter cube is equal to dash gram per cc. It's 1000 gram per cc. So I'll put 1000 over here. It will, sorry, it's reverse. 1 gram per cc is 1000 kg per meter cube. So 1 kg per meter cube is what I need. So I'll take this below. It is 1 by 1000 gram per cc. So when I put that over here in place of kg per meter cube, it will be 13,600 into 1 by 1000. Since divided by 1000, 10 power 3 is there, I'll just move 3 decimals. It will be 13.6 gram per cc. Okay, this is how we convert. Remember, unit factor should be known for both cross multiplication as well as unit factor method, for both of them. Okay, yes. Next one is pressure, which you already know, force exerted by gas per unit area, and then unit of pressure we mostly use in chemistry atm, sometimes Pascal, then Newton per meter square rare, bar little rare, torr sometimes. Question comes in torr. Okay, sometimes competitive exam question comes in torr, which is nothing but mm in place of mm. As you can see here, 760 mm of Hg is equal to 760 torr. So 1 mm is equal to 1 torr in case of pressure. I will discuss this in more detail when states of matter we are handling. Okay, yes. So all of these are few units of pressure, and then few conversion. Our atmospheric pressure, the pressure of atmosphere is 1 atm. So that is our reference. From there 760 mm is the mercury height, which I'll explain in detail later. This or else it can also be 101.325 kilopascal or 101,325 pascal, which is 101,325 Newton per meter square. Okay, yes, 760 mm of Hg can also be 1.01325 bar. Okay, yes. So this relation is something very important to note. 1.01325 bar is 1 atm. Okay, from these two I can make that relation. 1.01325 bar is 1 atm. Atm is smaller, always remember, atm is smaller, bar is bigger. Almost same both are, but it is bigger by this factor, 1.01325. Okay, yes. Convert 50 torr into atm. How much is 50 torr into atm? I told you already that 1 mm is 1 torr and 760 mm is obviously 760 torr. So also I know 760 mm is 1 atm. So from these two, can I say that 760 torr is 1 atm? Yes, because 760 mm is 760 torr also, 760 mm is 1 atm also. So I can say 760 torr is 1 atm. So 50 torr will be how much? Yes, either you can use factor method. If you want to use factor method, I can tell 1 atm is equal to 760 torr. So 1 torr is basically from one scientist whose name is Torricelli. So he gave that unit, that's why it became torr. So if I want in atm, it will be 1 by 760 atm. So 50 torr, if I want to calculate in atm, let's say n atm, then for torr I have to put the unit factor, which is 1 by 760 atm equal to n atm. So atm will get cancelled. 50 by 760 is the answer, which will be 0.066 atm. Clear? Yes. Going ahead, convert 2.5 atm into pascal. This also can be solved in a similar way by using the unit factor method. Okay, for now I am just leaving it. Yeah, we'll look into it in more detail later. Okay, yes, joule is the SI unit of heat energy, and here are few of the unit which we'll be looking: joules, calories, and electron volt. Yes, and remember this conversion is little important, calorie to joules. Okay, 1 calorie is 4.184 joules. Yeah, convert 3 calories into joule. Again, we can use unit factor. So 1 calorie is 4.184 joules. So I can say 3 calories equal to n joules. So in place of calorie I can put 4.184 joules, which is equal to n joules. So joules will go away. N is 3 into 4.184, which is 12.552 joules. Clear? And then there are few standard conditions which we will come across again and again in physical chemistry. Basically, we'll do this in states of matter. One is standard temperature and pressure. What is this STP means? It is defined as that condition, yeah, wherein temperature is 273 Kelvin of the system of the atmosphere where you are conducting that experiment, and pressure is 1 atm. Clear? So such a condition we call it as STP. Many times we conduct various experiments in certain condition, and this STP is one such condition. Okay, and when you consider 1 mole of an ideal gas, it occupies 22.4 liter. This is something very important. This previously also you might have come across this figure. 1 mole of an ideal gas at STP occupies 22.4 liter. Yes, instead of 1 atm, if you take 1 bar as STP, sometimes some new convention says 1 bar pressure as new convention. So then the volume of ideal gas won't be 22.4 liter, it is 22.7 liter. Okay, so STP condition, when it is defined as 273 Kelvin and 1 atm, it will be 22.4 liter. When it is 273 Kelvin and 1 bar, it will be 22.7 liter. Okay, similarly we have SATP condition, which is defined as temperature of 25 degrees Celsius, which is 298.15 Kelvin, and 101 kilopascal, which is nothing but 1 atm. Okay, and then there is NTP condition, which is defined as at a temperature of 20 degrees Celsius and 1 atm. Clear? So these are few of the standard condition, and yes, these are few of the things which you can know, that atmospheric pressure will be almost always 1 atm, and temperature, normal temperature we consider usually as 25 degrees Celsius. Yes, yes, we assume certain condition like liquid and gases are always pure whenever we are conducting some titration or some observation. Okay, yes, thank you for being for this introduction class. From next class we will begin the core thing of physical chemistry, scientific notation and all of those. Hope you all understood our discussion. Okay, thank you, and here.